Hey Falcons, today what we're going to talk about are single replacement reactions. Single replacement reaction is one where an element, in the example I'm going to give you in the demonstration, I'm going to give you magnesium, replaces an element that's part of a compound. So in this case, what I have here is the magnesium metal. It's a silvery wire. I've broken off several pieces of that. And then over here what I have is hydrochloric acid. This is a 12 moles per liter container of concentrated hydrochloric acid. I've diluted that, so what's in here is 3 moles per liter hydrochloric acid, so a much more dilute mixture. I'm going to add this to it, and what you're going to observe is the production of two things. Magnesium chloride, AQ, which means aqueous, dissolved in water. You actually won't see that. It's a white salt that is going to be dissolved in the water, so it won't be visible to you unless I was to dry or heat this until all the water evaporated, then you'd see white salt crystals. But what you will be able to see is hydrogen gas. And obviously hydrogen gas, you'd be able to recognize that through some characteristic bubbling. So I'm going to add these to the container now, and what you can hear and see is the production of that hydrogen gas. You can see the bubbling that's occurring, and you can see some vapor coming out at the top as well. That vapor may actually be some water vapor as well, because this is an exothermic reaction, meaning it's producing heat, which could be vaporizing or some of the water that's dissolved in this mixture. It's actually getting warm to my fingers to touch it at this point. So I'm going to set it back down, but this is a single replacement reaction. Why does this occur? It occurs because magnesium is more attractive to chlorine than hydrogen is. How would you know that? On the back of your periodic table, there'll be an activity series, which is a reactivity list for positive cations or metals. And it would list them in order of most to least reactive. And so because magnesium is more reactive or higher on that activity series than hydrogen, it's able to replace it and then form the compound magnesium chloride and produce those hydrogen gas bubbles. If I was to do this with another metal like gold or copper and drop that into hydrochloric acid, you would actually see no reaction. Why? Because those metals are lower on the activity series. Chlorine would find hydrogen more attractive than gold or silver or copper and would not react with it. It would not leave its bond to hydrogen to bond with those elements. The second reaction that I have here is zinc with hydrochloric acid, another element that is higher on the activity series than hydrogen, and so is able to replace the hydrogen in that compound, making another aqueous compound called zinc chloride, and again producing hydrogen gas. As you're looking at this, that bubbling that you're seeing is again hydrogen gas bubbles being formed, which I've now trapped in a balloon. And if you were to look at the bottom, you'd see the zinc metal kind of bubbling as it's being corroded or reacting with that hydrochloric acid. The hydrogen is being replaced by the zinc metal and forming these bubbles. Why am I showing you the same reaction essentially twice? I'm showing it to you because I wanted to trap these bubbles and show you a secondary reaction, a repeat of one you've seen earlier, which is a synthesis reaction, but I'm going to have to take you over to the fume hood to show you that. Okay, so what I've done now is I've taken the hydrogen gas that was trapped as a result of this reaction. So I've taken the balloon off and I've simply taped it to a meter stick. So what this has is gas, this is now filled with just that hydrogen gas. Interestingly enough, for those of you that study history, this is what happened in the famous Hindenburg Explosion, also on the cover of the Led Zeppelin 4 album. But what happened in that particular tragedy was they filled this gas into a Zeppelin or blimp. And because it's lighter than air, less dense than air, it's a good flotation gas. Typically we use helium, which is a noble gas, which is much safer because it is totally non-reactive. But interestingly, the Hindenburg, which was a German blimp, was experiencing an embargo from the United States on helium, so they filled their blimp with hydrogen instead. And that blimp, tragically, came too close to some power lines, I believe, and as it came too close, a spark was generated, and when that spark was generated, the hydrogen in there, when the spark was generated, first broke the seam of the blimp, and then that gas was able to react with the oxygen in the air and this is what you would see.
Yeah.
Again, a very exothermic synthesis reaction. Thanks, Falcons.